Hello everyone. Today we're going to discuss a new topic. So today's topic is called highest common factor or HCF. Now you might have heard about this term earlier, but today we'll be discussing in details how this HCF can be found out through different methods. Although all the methods would give us a similar kind of result, but we will be discussing all of those methods. Then you can prefer as you wish which one you would like to follow for finding out your result. So before beginning, first of all, let us go through a recap of what is actually the highest common factor or HCF. So HCF of two or more numbers is the greatest number that divides each of the numbers without leaving any remainder. Yes. So whenever we find HCF, there should be at least two numbers. We can't find out the HCF of one number. No, we can't do that. So there should be at least two numbers, or more than two numbers also there can be. So whenever, say for example, we are finding out the HCF of two numbers, say 2 and 4, although I have not given any example here, but say for example 2 and 4, then HCF will be such a number or that greatest number which can divide both 2 and 4 without leaving any remainder. So can you think about such a number which will divide both 2 and 4, a greatest number? Yes, obviously the answer is 2, isn't it? Or not? No, it is not. Here it will be, which will be the highest? For this you have to find out the factor, since it is given HCF. So what are the factors of 2? 2 and 1. And what are the factors of 4? 1, 2 and 4. So which is the highest common factor here? Although the common factor is 2 here, and other than that there are no factors. So obviously the HCF of 2 and 4 will be 2. Because that is the only common factor here. If there are more common factors, then among those common factors, which is the highest, that will be the highest common factor. Now we'll come to that later on. In the upcoming slides, we will be knowing through the methods that what is actually the highest common factor. Now next point is, it is in fact the greatest of the common factors. Yes, as I have said, we have to find out the factors first of all. Any two numbers, say if you are given, first of all what we need to do is we have to find out the factors. Now you might be thinking, either are there these prime factors? No, there can be any factors, just the factors. We have learned about multiples and factors. So we have to just find out the factors. So then among those factors, which is the common factor we have to see? Then among those common factors, which is the greatest common factor, that will be the HCF. That is why it is also sometimes called as the greatest common divisor. Why it is called divisor? Because it divides all the numbers without leaving any remainder. Clear? Now we will see its practical use. Now first method of finding HCF is the factorization method. So obviously the name as says, it is factorization, then definitely we have to find out the factors. Also it is the general rule, you can say, of finding out the HCF. So suppose we have two or more given numbers, then how to find out the HCF through the factorization method? There are some steps. Step 1, find all the factors of the given number. Yes, whatever number is given, as I have said in the earlier slide, you have to find out all the factors of those numbers. In this way, say for example you are given 18, 24 and 30. Now you are told to find out the HCF of this. So what we did is we have found out all the factors of 18, all the factors of 24 and all the factors of 30. Then after that what we need to do is, then we have to find all the common factors. So we have to see which are the common factors. 2, yes, it is 2 is there in every, 2 is there in 18, 2 is there in 24 also, 2 is there in 3 also. Yes, 1 is also there. Obviously 1 is a common factor of any number. Then we have to see next which is the common factor 3. Yes, 3 is there in all the 3. Then 6, no, 6 is, yes, 6 is also there. So then we have to see which are the common things. Then after that we have to see which is the largest common factor. So among this The common factors we got already 1, 2, 3 and 6. So which is the largest common factor here? Obviously 6. This is the largest number also. But we will not be considering it as number, we will be considering it as a factor. So 6 is that largest factor which is common to all these three numbers 18, 24 and 30. So obviously 6 will be the highest common factor or HCF. Clear? Now next, moving on by finding out the HCF through the prime factorization method. Now just this is a you can say upgraded version, you can say something like that, because here also same method of factorization is only performed, but here we have to only focus on the prime factors, not any other factors, only the prime factors. So let us see how to do this. Suppose we are given same thing, 2 or more given numbers, then we will proceed in this way. Step 1, first of all, same thing as the factorization method, same thing, but to find all the prime factors. There we have found out all the factors, but here we have to find out all the prime factors. So whatever factors it will be, those will be prime numbers. So here is one example given, 72 and 90. So we have found out the factors, but if you see carefully, all the factors are prime numbers. 2 is a prime number, 3 is a prime number. It may repeat, no doubt in that. So we have done it in this way. Division kind of method, you can say. This is also related to the next method, we will be discussing that. So in this way we have found out all the factors. Then next step, what we have to do, we have to find all the common prime factors. How many prime factors are common here? 2 is common. Then again 2 is there, no. 3 is common once, 3 is common twice. Then 5, no. So only these are the common factors, 2, 3 and 3. No matter how many times it's repeated, but you have to see how many times it is repeated here also and here also, in the other number also. Then only we can say they are having something common. So how much we got? 18. So this 18 will be the highest common factor of 72 and 90. Now one important thing that you will notice here is that in this method we will not get our factor directly from the factorization. Here what will be the product of those common factors, that will be the HCF of the numbers. Clear? So this is one of the main difference between this method and the earlier method. Here the product of the factors will give us the HCF, but in the earlier case directly the factors itself has given us what will be the HCF. Clear? Now next method is the common divisor method. Here also same thing. Here also means we have to follow some steps, but the method is a little bit different than the earlier one. Let us see how it is. In the step 1, we have to arrange the given numbers in a line or any order. Whatever numbers are given to us, say 2 numbers or 3 numbers, whatever, we have to arrange them in an order. Say for example 60 and 72. Yes, we have arranged them in one order. Here we have arranged in ascending order, you can say 60 then 72. Now then what we have to do is that next step, we have to divide the numbers by the lowest common prime number. Here also prime numbers are taken into consideration. Here whatever factors we will get, all will be prime. So lowest common prime. So here the lowest common prime is 2. So we'll divide by 2 since it is divisible by 2. So this will be the lowest prime. So if it is divisible by 2, then 30 and 2, 36. Then again same procedure we have to repeat. Then here in 15 and 18 it is not divisible by 2. So here next lowest prime number will be 3. So we'll divide by 3, 5 and 6. So then we have to continue this. Then divide the quotients by the lowest common prime number. We have to continue this until and unless no more common prime numbers are there to divide. Now can we divide again 5 and 6? Any common prime number is there? No. 5 and 6 we cannot divide by any other prime number, common prime number. So we have to stop this procedure there and there. Then what we have to do is that we have to find out the product of the divisors. These are the divisors. These are not the divisors. Whatever is on the left hand side, these are the divisors. So 2 into 2 into 3, product we have to find, that will be 12. So this 12 will be the HCF, required HCF. So there is some similarity between this method and the earlier prime factorization method. The similarity is there. There we have seen the common factors, but here we have not seen any common factor. We have taken only such a prime number which is common to both. So it has already become a common factor by itself. Then only the divisors, this will be now considered as the divisors, or the divisors. So whatever divisors we get here, just we have to do that product, and then that will give us the HCF. And we'll do this division method unless, as I said in the step 4, that there is no more common prime left. Then when such a condition arises, they have to stop. Clear? Now the last method here, that is the division method. That was common division, now it is division. Now let us see what is the similarity or the difference from the earlier method. So here also some steps will be followed. Step 1, divide the larger number by the smaller number and obtain the remainder. Okay. Here if suppose 2 numbers are given, then what you have to do, mainly this is followed, for example 2 numbers. Even there are more than 2 numbers, we can do it, no problem in that. So here you can see that we have to find out the HCF of 217, 385 and 735. So what we'll do is that first of all we will take any 2 numbers. Clear? We'll take 2 at a time. We will not take 3 at a time. We can't take that. First of all, we'll find out the HCF of any 2 numbers. Say if we have taken 217 and 385. Then what we do is that since 385 is the larger number and 217 is the smaller number, so we'll take 217 as a divisor and 385 to be divided. That is, this is the thing we have to do. So we'll divide it. Now we'll divide it. How many times it goes? We'll get a remainder, obviously. Now next what we'll do is that whatever will be the remainder, that will turn to now divisor. And whatever was there as the divisor earlier, that will now become, that has to be divided now. Clear? Divide the divisor by the remainder. Yes. That is what we need to do. Again we'll get the remainder. Then same thing continues until and unless, this process will repeat until and unless we get a remainder as 0. Clear? Now how to find the HCF? Sorry for the inconvenience. So how to find the HCF? Now after repeating, if you see here carefully, what did we get at last? We got 7 as the divisor. So this 7 will be the HCF of this 217 and 385. Whichever divisor we get at the last, that will be the HCF of that 2 numbers. Then same procedure we can repeat. Now here which numbers will be taking? The HCF of these 2 numbers and this remaining third number. Clear? So 7 next HCF what we will do? Same procedure will follow. We have to find out the HCF of 7 and 735. So whatever result we get there, same procedure, that will be the HCF of these 3 numbers. So we can say that if we have to find out the HCF of 3 numbers using this division method, what we need to do is that we have to first find out the HCF of the first 2 numbers, then we have to then whatever the result that we get or whatever HCF we get of the 2 numbers, we have to then find out the HCF of the resultant number and the whatever number is left. Clear? So these were the 4 methods of finding out the HCF. Now if no method is mentioned, you can use any of the methods. The answers will be the same or the result will be the same. But if it is mentioned specifically that this method has to be used, then you have to follow that procedure. So I hope you all have understood these 4 methods very well, I guess. There are many examples in the book. You can try it out for yourself. You can try it out to find out the HCF of any 2 numbers or any 3 numbers by all the 4 methods and check for yourself as an activity that whether all the methods give us the same result or not. You can try it out. Obviously they will give you the same result no matter which method you follow. So that's it then for today. Thank you and have a nice day.